All right. So the last section of this chapter is not difficult at all, but it deals with a very special topic, which is interest. Interest is used everywhere, whether or not you get a credit card or a loan, or maybe you have a couple of dollars and you want to invest money so that you can earn interest later on at a future date to have some more cash. So let's first define a couple of these, couple of the definitions that we're going to be using here. So the first is going to be interest. So interest is a charge for using, borrowing, or investing money. Okay. If you borrow money, the interest is charged. And if you are investing money, the interest is earned. Okay. The principal is going to be the initial amount. All right. It's going to be the money borrowed or invested. And it's going to be, like I said, the initial amount. Okay. Time. Time is going to be how long the money is borrowed or invested. And it's always going to be in years. Okay. Now, the formula for simple interest is right here. So I'll block it in. So simple interest is going to equal the principal times the rate times the amount of time, or in symbols, I equals PRT. Okay? So let's just look at some very simple problems. So the first one here is going to be, let us find the simple interest after 2 years on a $500 loan at an interest rate of 12%. Okay? All right, so to do this, it's best to just label everything. We know the formula that we're going to be using is I equals PRT. So off to the right here, I is going to be the simple interest. Okay? P is going to be the principal. It's going to be how much I borrowed. R is going to be the rate. Now, it has to be a decimal. Okay? Got to be a decimal. It's always going to be given to you as a percent. You have to convert it to a decimal. And then T is going to be time. And remember, that's always going to be in years. Okay? So for us, I is going to be the question mark. That's what we're looking for. Our principal, the amount that we invested, $500. The rate is 12%, but as a decimal, that's going to be 0.12. And then the time is going to be 2 years. So we substitute each of these values into our formula. 500 times 0.12 times 2 is going to equal $120. Okay? So that's how much the interest is. But let's say I want to further extend this problem. Find the total cost of a loan that has been invested or borrowed. I don't want to say invested. Let's say borrowed for 2 years at an interest rate of 12%, and the initial amount borrowed is $500. So in other words, I'm just extending the previous problem. So from the previous example, we know the interest was $120. Okay? Now, the total amount borrowed and this even applies to invested, is going to equal the principal plus the interest. So for our problem, the total amount borrowed is going to equal the principal. Well, we initially borrowed $500. We know after 2 years, we're going to pay $120 in interest. So the total amount borrowed is equal to 500 plus 120 is $620. Okay? And that's it. It's not too bad. All right? Let's look at another problem here. We'll do one more. Okay? An accountant invested $2,000 at a simple interest rate of 10% for 2 years. Okay? What total amount of money, what total amount of money will she have from her investment in 2 years? Okay? So let's break this down. We know they're asking for total money. So we know they're asking for total money invested, okay? And we know that's going to equal the principal plus the interest. All right? Well, we already know the principal. The principal is $2,000. So in my equation down here, directly underneath the word principal, I can write 2,000 if I wanted to. The question becomes, how much interest is she actually going to earn? So interest is going to equal the principal times the rate times time. And off to the right here in this little block, in this little box I'm going to draw. All right, it's always good to label. So the principal equals 2,000. The rate is 10%, which is 0.10 as a decimal. And then the time is 2 years. So I is going to equal 2,000 times 0.10 times 2. Okay? So 2,000 times 0.10 times 2, the simple interest earned is going to be $400. So in my equation above, I can erase the question mark and put $400. So the total money invested is going to equal 2,000 plus 400, or total money is going to equal $2,400. Okay? Not too difficult. So the last example we're going to deal with is called compound interest. Okay? Now, the difference between simple interest and compound interest is the fact that with the simple interest, okay, let me go all the way back up here. All right? With the simple interest, all right, this is compounded once a year. Actually, no, it's just compounded once. Which means if you take out If you take out a $500 loan, 12% for 2 years, all right, you're going to owe $120 in interest, which we found right here, all right? And then the total money you're going to owe at the end of that is going to be $620. That doesn't change, okay? With compound interest, what's happening here is I'm going to compound the interest on the principal multiple times per year, okay? So the formula for this, so the total amount A in an account is given by A equals P times 1 plus R over N, all raised to the N times T. Now, I know this looks confusing, so we're going to label everything. A is going to be the amount, okay? That's usually your total. P is the principal. That doesn't change. R is the rate. N, actually, let's save N. Let's do T for time, okay? Now, the reason why I wanted to save N is because this is the new thing. N is how the money is compounded, okay? It's how the money is compounded, all right? Now, N can take on many different values. So let me put a star here. N can take on many different values. So for example, I'm going to put a little N here. Let's do a column. I think a column is going to work out nicely. So N, and then how it's compounded. So for example, if the money is compounded, let's say daily, then N equals 365. In fact, now that I look at it, I'm going to change these headings. I'm going to put how it's compounded. I wrote it backwards by accident. And then just what N equals. So if the money is compounded daily, N equals 365. If the money is compounded monthly, N equals 12. If the money is compounded weekly, N equals 52. Okay? If N is compounded quarterly, N equals 4. If the money is compounded annually, N equals 1. And if N is compounded semi-annually, N equals 2. Okay? And those are the most popular ones. Okay? So let's just look at an example and let's compare how simple interest differs from compounding interest. Okay? So let's say $1,800 is invested at 2% for 3 years. Which is the better investment? Which is the better investment? All right, and we're going to compare the two. We're going to compare, I don't want to put letter A, we'll just put this. We'll put simple interest, okay? Or compounded quarterly. Okay? So with the simple interest, we know the total amount is going to equal the principal plus the interest. So let's find the interest first. So we know it's going to be 1,800 times 0.02 times 3. Okay? So for the simple interest, we get 1,800 times 0.02 times 3, or I equals 108. So the total amount equals 1,800 plus 108 or 1,800 plus 108 is $1,908, okay? So that's if we invest our money using just simple interest. Now, let's see compounded quarterly, okay? So for compounded quarterly, we have to use this formula here. So the amount equals 1 plus r over n, all raised to the n times t power. And like I said, I know this looks confusing, but if we just take our time, okay, if we take our time, it's actually it's a very simple formula to use. So A equals the principal, 1,800, times 1 plus the rate is 0.02, divided by, now, the money is being compounded quarterly, so that's going to be a 4, and then we raise it to the 4 times 3 power, okay? So just to simplify this a little bit, I get 1,800 times 1 plus 0.02 divided by 4, all raised to the 12th power. Now, I'm not going to rush this, okay? I'm going to do each little step so you can see exactly what's happening. So A equals 1,800 times 1 plus, I'm going to do 0.02 divided by 4 first, because I got to do the work inside the parentheses, and division becomes before addition. So it's going to be 0.005, all raised to the 12th. All right, now I still have to do the work inside the parentheses. So 1 plus 0.005 is 1.005, all raised to the 12th. Now we need to do the exponent. Let me highlight what I'm talking about here, because I know some of us may want to do 1,800 times 1.005, and that's incorrect. We have to do this first, what's highlighted. Now, my suggestion, honestly, I would just get a calculator and just type that into my calculator, okay? So 1,800, it's going to be 1,800 times 1.005 raised to the 12th power is 1.0617. We'll round the 4 decimal places, okay? And then last but not least, we just take these two numbers and multiply them. And it gives me $1,911.02. So, which is the better investment? Well, the better investment is going to be the higher amount. So it's going to be the money that was compounded quarterly. And there's the major difference. With simple interest, the money is just, you apply the interest once and that's it. It never changes. However, with compounding interest, you will compound that money however many times per year, okay? So if you are borrowing money, you want it to be simple interest, because what you borrow is what you get. That's what you got to pay back. If you're investing money, you want it to compound as much as possible. Okay? And that's going to be it for this lecture and for this chapter. We only have one section left, which I think is 7.3. So I will do a video for you for 7.3. And what's crazy is that is the last section. That is the last thing we're going to be learning for the entire semester. All right? So I hope you found this enjoyable, and I hope you found this informative. I'll see you in the next lecture. Bye.